this is the activity we're doing today. I'm basically going to walk through how to do it here. And then I'm going to have you guys do a couple on the Zoom here. And I want you guys to send me your answers in the chat, just to make sure that you know what you're doing and I can kind of help you out a little bit with it. But after, I know what you know what you're doing, you can go ahead and log off and just log back on if you have more questions. Okay. So the rearranging atoms activity, first thing we need to do is define these four terms. Now, four of these terms, subscript with the chemical formulas and coefficient and reactant and product, I defined in the video yesterday. So if you watch that video, this should be in your notes. The only one I didn't define was conservation of mass, but I did talk about it. So there wasn't a slide that you might have written anything down on, but I did talk about the conservation of mass in that video. So what I want you guys to do, everybody take a few minutes and either do this on a separate sheet of paper, or if you've printed this off, you can just write it directly on there. Yeah, go ahead and define all four of these, please. Everybody take a couple of minutes to do that, and then I'll go over the answers. No, that's fine. You don't have to put them in the chat. You can just write them down on your worksheet. I'm going to ask people for the answer, but I'm giving everybody a chance to like try it on their own. So, and then we'll go over them so that everybody actually does have the answers. So. Okay. Okay, so what I'm going to do here is see if I can get some volunteers for someone to tell me what these things are. Can someone volunteer to tell me what conservation of mass is? Go ahead and unmute. Can't be created or destroyed. So that means we have the same amount of material, number of atoms, basically, same amount of material before and after. That's going to be very important for these chemical reactions that we're doing. Okay. Somebody else is coming in here. So we do have the same number. Like you can't just create any material from nothing. You got to have something to start with, and it can't be destroyed. So, like when I do a chemical reaction, I'm going to have something being created, but it came from somewhere. So I have the exact same amount of material, both before and after that chemical reaction. Okay. So volunteer for chemical formula. It looks like, okay, so yeah, we would have 2 irons and then 3 oxygen. The charges balance each other out. So we've got I'll make blue for this one. We got an Fe, another Fe, and then so these little subscripts here tell you how many of them you have. Okay. Good. So let me give you an example here. 2H2O. Okay, there's a 2 and there's a 2. Let me just change it. I'm going to change this to a 3. There we go. Then it won't be the same number. So a 3 and a 2. Okay. So if I have a 3H2O, which number is the coefficient? Got a bunch of people answering there. Good. You guys all got it right. The 3 is the coefficient. What that 3 is telling me is I actually have, I'm going to use 3 water molecules. Three water molecules. Everybody follow that? That's what that 3 represents. Now, each water molecule has 2 hydrogens in them. So there's 2 here, there's 2 here, there's 2 here. The 2 is a subscript for the formula. Okay? So we've got 2 different numbers here. The 3 in front tells how many water molecules we have. The 2 tells me how many hydrogens we have. And then technically there's like a 1 that we don't bother writing there. That's 1 oxygen. So we've got 6 hydrogens total here, 3 oxygens total here, 3 water molecules, each with 2 hydrogens and 1 oxygen. Okay, that's what all of this means. And those are the words to describe that. Coefficient is that number, how many I have. Subscript are these numbers, how many elements are in the molecule. Okay, all right, last one. Good way to put it. So reactants are before, products are after. Okay. Short and sweet there. It's just 2 words to describe the 2 halves. Reactants are the things I'm reacting that I start with, and then products are the things that I create. So that's what I have afterwards. Now, law of conservation of mass, reactants and products are going to be the same amount of material. Okay, it's going to be the same amount of material, which is kind of what this activity is about. I'm doing this with colored markers, guys. I don't know if you guys have colored pencils or markers or anything like that, but I find it easiest with colors. You don't have to use colors though. But what I'm going to do, I'm going to walk through these first 2 example problems here. Okay. What I'm going to do here is I am going to draw this reaction here. Okay, so I have a reaction, sodium, Na, it reacts with water, H2O. Those are my reactants. They turn into sodium hydroxide and hydrogen, which is one of the diatomic elements. So it's H2. Okay, and those are my products. So 2 reactants and 2 products. I'm going to draw these. So I'm going to use blue for my sodium. I'm going to just do an Na and circle it with blue there. You don't have to use colors. You can just, do a little Na there. Then oxygen, I'm going to do a red O. Then I have 2 hydrogens on there. Okay, so that's a water molecule, right? On the other side, I've got a sodium hydroxide, an oxygen, hydrogen here. So this is all one thing. NaOH, it's got 3 atoms in it, okay? And then we have hydrogen, which is 2 atoms of it connected together, so it's a hydrogen molecule, H2. Right? That's what these subscripts are telling me in the picture that I just drew. Right? Now, according to the law of conservation of matter or mass, those should be equal. Are they? Do I have the same amount of material both before and after? It's got like 4 of you guys who said in the chat, nope, no, no. They are not equal, especially if you look at this picture. What's not equal here is the hydrogen. Does everybody see it? So I've got 3 hydrogen atoms in the products, but only 2 in the reactants. So somehow a hydrogen atom magically appeared. You know what I mean? That's not possible. So what we're going to do, in order to get that hydrogen that we need, we're going to basically start adding on both sides until we actually get the right amount where it is actually equal on both sides. So since I have 3 hydrogen here, I need at least 3 hydrogen here. Okay, so in order to put more hydrogen, though, I can't add just a single hydrogen like I need because that's not what's up here. What I have up here is sodium and water. So the only things I can draw are sodium and water. So if I want another hydrogen, I have to draw another water in order to make that happen. Okay, so I have to add all of the rest of the pieces, which technically I didn't need, but that's how this works. You have to add everything in that molecule because you can only have these things here. You can only have water, you can only have sodium. Okay, so now I didn't fix my hydrogen problem. I still have too much hydrogen, but I flipped which side it is. You guys see that? It was 3 and 2. Now it's 3 and 4. So I've got too much hydrogen over here. I need more hydrogen over here. So I'm going to do the same thing. I'm going to add hydrogen to this side. Now, hydrogen's in both of these. I only need 1. So I am going to add hydrogen. I'm going to add the one thing that only has 1 hydrogen. Okay, I'm going to add the NaOH. So let me add this to it. We have Na. I have to add the whole thing. O. H. And that gives me 4 hydrogens in the products and 4 hydrogens in the reactants. So now I am not creating or losing any hydrogen. Law of conservation of mass works for hydrogen, at least. Okay. It also now works for oxygen. Everybody see it? There's 2 here and 2 here. Now, when I added that extra water, I didn't even look at the oxygen, but I added this to fix the hydrogen and it fixed the oxygen as well. Like I created the problem and fixed the problem without even thinking about it. I was focused on just one element and it fixed another element for me. That happens a lot, okay? It's still not perfectly balanced though. What's the problem now? Hydrogen and oxygen are fine. Sodium's off. So there are 2 sodiums here, but there's only 1 over here. Now, again, I can only add what's up here, and thankfully that is a single atom of sodium. So I can just add another single atom of sodium, and now it actually is equal. So you have the same amount of material in the before as the after. These match. All that's happening here is these atoms are rearranging to make these. Okay, that's what a chemical reaction is. Nothing is created, nothing is destroyed. So our last step, what we're going to do here is we are going to count how many we have and write them as coefficients in front. Okay, remember coefficient, how many you have. So I've got 1, 2 sodiums, 1, 2 water molecules, 1, 2 sodium hydroxides, the NaOHs, and only 1 of the H2s. So those are my coefficients telling me how many I have, right? Okay, let me do the next one. I'm gonna do 2 examples for you, and then I'm gonna have you guys do the one on the next page, okay? So this next example here, we have a magnesium nitrate. I'm gonna use purple for my magnesium here. There's my Mg. The nitrate, we have an NO3, parentheses around it 2. Now, what that means is that we have an NO3 and then we have another NO3. Okay, so we have an N with 3 oxygens. O, O, and O. And then we have another one of those. We have an N, O, O, O. An NO3 and another NO3. That's what that means, that parentheses 2. Okay. Then we have our sodium hydroxide, Na, O, H. It should be equal. That's what we're kind of seeing here. Okay. And then we have our sodium hydroxide, which we're making, Na, NO3. Okay. And then our magnesium hydroxide, an Mg. And that is an OH. So we're going to do an O, H. And then there's 2 of those, so another O and an H. Okay. Madison, you asked me a question. I'm not quite sure what you mean, but I'm going to have to come back to that. I don't think the answer is yes. All right, but come talk to me in a little bit about that. I'm not sure what you mean by that. But looking at this diagram here, they should be equal. They are not. They're most definitely not. In fact, almost every element is off except for the sodium and the magnesium. I mean, there's a lot of colors here, but there's 5 of them. There's 1 sodium and 1 magnesium on both sides, but everything else is off. Okay, there's 2 nitrogen and 1 nitrogen. There's 1 hydrogen and 2 hydrogens. And then there's 1, 2, 3, 4, 5 oxygen over here, and 1, 2, 3, 4, 5, 6, 7 oxygen over there. Okay. Now, first thing when looking at this giant mess, you will notice that even though oxygen is off, there is an oxygen in every single thing. Everybody see that? Everything has an oxygen in it. Do not do an element that is in every single thing. Okay? Unless you absolutely have to. If it's the only element that's off, then you're going to have to do it. But if you have other elements that are off, don't do the one that's in everything, because kind of it's the answer. I need to add more oxygen over here, but do I add more of this or do I add more of this? You see what I mean? You can add both to get more oxygen. So don't do oxygen and do one of the other elements. And then oxygen will actually probably just fix itself. That'll happen like 95% of the time. All right. So if it's in all of them, don't do that one. Do one of the other ones and we'll see if it just fixes itself as we go. So I'm going to do either nitrogen or hydrogen. Okay. Let's do nitrogen first. So nitrogen. I've got 2 nitrogens over here on the reactant side. 1 nitrogen on the product side. So I need to add another nitrogen on the product side. This is the thing with nitrogen. So I'm going to add another one of those. Okay. Another Na. An N. O, O, O. Okay. So now I have 2 nitrogens and 2 nitrogens. Nitrogen is fixed. Okay, I got equal numbers of nitrogens on both sides. Hydrogen was the other one that was off. Okay, I did mess up my sodiums, but we'll come back to that. Hydrogen was the other one that was off. I have 2 hydrogens on the product side, but only 1 on the reactant side. So I need to add another hydrogen on the reactant side. So I'm going to add another one of these NaOHs. Okay, so now I have 2 hydrogens and 2 hydrogens over here. So those match. So my nitrogens match 2 and 2. My hydrogens match 2 and 2. My sodiums match again. It screwed up when I did this, but now it fixed itself. Then you have to think about it. So my sodiums match. My magnesium still match. So that's 4 of the 5 elements. Oxygen's the last one. It's in everything. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen just fixed itself. So they are equal. Same number of atoms, same amount of material, both before and after. Okay. So once you get that, all you got to do is count. I took 1 of these, 1, 2, 2 of those, 1, 2, 2 of those, and 1 of those. So those are my coefficients. So you don't have any questions over anything I did? No. Somebody had a very emphatic no. All right, let me pull up the document again. Let's pull this down there. Hold on. And there we go. So I just did those 2. What I want you guys to do is let's do the next 3. Okay. I want you to do 3 of them on Zoom with me here. Does that sound fair? So 3 of them on Zoom with me. Please send me the answers to the first 3. And then I will know kind of what you're doing. If you give me wrong answers, I'll obviously try to help you here. But once you got the first 3, I think you'll get the general idea, and you guys can go ahead and log off and work on it yourself. Okay. So go ahead and take the time. Send the answers to me in the chat. Don't forget to change it to private, please. If you just tell me the coefficients, you can write the whole formula if you want, but if you just tell me the coefficients and which number you're doing, that should be fine. All right. You can either do them individually or all 3 at once. I don't care. Okay. Once you guys have gotten all 3, you can go ahead and log off. I'll see you guys tomorrow for small groups, and log back on if you have any more questions, though. got more people logging off than I've actually responded to. Nope. All these people who are sending me answers and not waiting for a response, almost every single one who's just responded and then logged out without waiting for me. Yeah, you didn't get it right. Like they're not getting it right. So okay. So this first one here, I'm going to walk through it. We have hydrogen, which is an H2, oxygen, which is an O2. They need to be equal to O with 2 hydrogens. Okay, so that is 2 hydrogens and an O. Sometimes people get that mixed up and they do 2 O's and a hydrogen. Okay, so be careful of that. Oh, I used the wrong color. Right? Now, the hydrogen's fine, but the oxygen's not. Okay, there's 1 oxygen and 2 oxygen. So what I'm going to do is add another oxygen over here by adding another water molecule. Okay, now oxygen's fine, but that screwed up hydrogen. So now I've got 4 hydrogen on this side, so I need 4 hydrogen on this side. I got 2 right now, so I'm going to add another of the H2s, and that gets me 4. So the answer would be 2 of these, 1 of these. We're going to make 2 of these. Okay. So that's number 1. Number 2. Okay. So number 2, we have an H2 and a Cl2, and they create an HCl. Okay. So we're going to use blue for H, green for Cl, and then we will have a Cl and a H. And we're done. And both of these sides should be equal to each other. Currently, they're not. So both hydrogen and chlorine are off. We've got 2 H's and 2 chlorines, and then over here we have 1 H and 1 chlorine. So with this one, I need to add another H over here and another Cl over here. So I'm just going to add a whole one of these HCl's. So this one would be 1 and 1 make 2. Okay. Now, a lot of you guys, I think, are getting off on this third one. Okay. So number 3 here, we have Na reacts with O2. It makes Na2O. Okay. So I'm going to use, we'll use purple for Na here. We got Na, O2, so an OO. And it should equal on the other side Na2O. So that is an Na, another Na, and then O. So that's your Na2O. 1 sodium, 2 sodiums, 2 oxygen, 1 oxygen. Neither of them are correct. Okay. So what I'm going to do here is I'm going to go, I know people are kind of giving me answers here, but I'm going to just walk through this here. I'm going to start with the oxygen. All right. So I have 2 here and only 1 of them here. So I'm going to add another one of these. Okay. But I have to add the whole thing. Na2O. So I got another Na, another Na. Okay, so there's my Na2O. Now I've got 2 oxygen and 2 oxygen. The sodiums, the Nas. I got an Na. It's 4. So I need 4 of them over here. Now, the reason I do the oxygen first is because that's a single one. So those single ones are always the easiest. So I do them last. So I need 4 of them. Well, I can just add 4 of them because it's literally what it is. So 4 of the Nas. Okay. We need 4 of these, 1 of these, and we're going to make 2 of those. Questions? So yeah, those 3, all done. You got the answers to them. You guys can work on your own. Log back in anytime till the end of the hour, and then I have office hours at 3:15 if anybody has any more questions. But let me know if you have any questions.